And we're live.
What we're going to try and do now is calculate acceleration. We're going to try and figure out, okay, how big is the acceleration? So, here we go. Let me make sure I am accurate here, following along. So, the acceleration of an object is dependent on a couple of things. It's dependent on the... Now, I wrote delta V, but how do we say that in English? What does delta stand for? Change in. I'm trying to use the symbols as much as possible in our notes, Justine, because you got to memorize them. So I figure the more you write them, the more you memorize them. If you want to, in brackets, write change in velocity, go ahead. Oh, and what's change in anything? Final minus initial. And what does T stand for? So, Timbits. The acceleration of an object, it depends on the change in velocity and the time required to change the velocity. Acceleration depends on two things, what your velocity change is and how long it took you. When stopping, you know what, we're going to come back to this and see if we can figure it out. Instead, I'm going to jump straight down to here, the equations of motion. This is what you get on your provincial exam. This is what's on your green sheet. What we're going to be looking at for the next couple of days then, Kenzie, are these six here. Now, they look very confusing, but I want you to notice, first of all, how can you calculate acceleration? It's what divided by what? That's not quite velocity. What does it say? Change in velocity over time. And what's change in anything? That they put on there. So any other change in, like a change in D or a change in T, hopefully you can figure out that that's also final minus initial. What if you want to find the initial velocity? Well, that turns out to be the final velocity minus the change in, if you know the change in. How can I find the change in velocity? Well, that's also the acceleration times the change in time. If you know the acceleration, the change in time. What I want you to realize, Dane, is in these equations, you're going to be moving back and forth. So maybe they say find the final velocity, and you can see the initial velocity, but you don't know the change in, but they gave you the acceleration and the time. You can find the change in. You're going to kind of have to make little lists and see what you can plug and chug and what you can plug in. So, based on this up here, when you're stopping a moving object, when you're bringing an object to a stop, the relationship between time and acceleration is, okay, here's time. Here's acceleration. Is acceleration on the bottom or on the top of this fraction? Bottom. If I put a bigger number on the bottom, what will happen to time? Or, let's look at acceleration. If it takes me longer to slow down, what happens to my acceleration? Well, let's think about it. How many of you have been on the Lougheed? Okay, speed limit on the Lougheed is 80 kilometers an hour in the stretch to the west of Pitt Meadows. How many of you have crossed the Pitt Bridge before? Okay. How many of you have hit the red light just before the Pitt Bridge before? So all of you have done a delta V, a change in velocity of negative 80 kilometers per hour, because your initial speed was 80, your final speed was 0. So going from 80 to 0, does that kill you? And the answer is, it depends. What does it depend on? How long it took you. If you take your time, Jessica, and you slow down gradually, no problem. In other words, if this time value is big, your acceleration is pretty small. If this time value is short, like in a collision, your acceleration is pretty big, and it's the acceleration that can be fatal in a car crash. So what we're going to write up here is this. When stopping a moving object, the relationship between time and acceleration is, if I increase the stopping time, that will decrease the acceleration. If you take longer to slow down, Sarah, it's easier on your body. You don't feel yourself pushing against the seatbelt as hard. If I slow down really fast, if you hammer the brakes, what happens to your acceleration? Okay? Okay? And the relationship between, what does A stand for? Change in velocity, and the time interval is given by, well, mainly by these equations, but we're going to be using all of these today. And the best way to do this is just to jump on in and start crunching some numbers, start practicing some examples. So example 1. Read the question to yourself. I'll read it out loud. A pool ball traveling at 2.5 meters per second towards the cushion bounces off backwards. You know what? That's probably an important word. I'm going to underline that because I think that's a direction. At 1.5 meters per second, if the ball was in contact with the cushion for 0.2 seconds, what's the ball acceleration? Assume towards the cushion is positive. Assume forwards is positive. First thing I always ask is, what the heck is this question asking me to find? Thankfully, in physics, that's actually fairly easy to figure out because almost always you'll see a word or a phrase like, what is, or find the. What are they asking me to find in this question? So I'm going to write down over here, A equals, and I do question mark. That's my way. That's my abbreviation for find that. Then I start reading the question again, and I list everything they told me. I'm looking for numbers and physics words. I'll talk about those in a second. But the first number that I run into is a 2.5. What's that? What are the units next to the 2.5? Okay, Curtis, what do I measure in meters per second? You need to know your units. Do I measure time in meters per second? No. Do I measure distance in meters per second? No. What? Which velocity is that 2.5? Your initial, before, or your final, after? I'm going to write down VI equals positive 2.5. Why did I write positive 2.5? Because it says assume towards the cushion is positive, so I'll be consistent. The next number I see is a 1.5. Kenzie, what are the units right next to that 1.5? It's actually on the next line, but what do you see? What do I measure in meters per second? Is that time, distance, or velocity? What was this 2.5 here? That's a velocity. Initial or final? Before initial or after collision final? What's that 1.5? Is it before or after? Amy, is it before or after? So V final or V initial? So let's write down VF equals, but I'm not going to write down VF equals 1.5. What am I going to write? Negative. Okay. I keep reading, Hayden. I keep reading. Reading. Hayden, the next thing I see is this number right here, the 0.2. What's that? Look at the units next to it. 0.2 what? What's that? Velocity, distance, or time? Time. By the way, it's well worth memorizing the units. It cuts down on your mistakes. And in Physics 11, a bunch of kids have signed up for it. I've looked at the list. I'll be yelling at you guys, memorize the units. You'll memorize them anyways, Justine, because you write them out so often, but it's worth doing. So Hayden has said T equals 0.20. I'm not going to write this, 0.2 seconds. So here is the deal. I'm looking for acceleration, so I want to find an equation that has the A by itself. Which one does? I'm going to write down here A equals, and I got to be fussy, it doesn't say velocity over time. What does it really say? What's change in anything? What's V final? Negative 1.5. Now it's plug and chug. Now it's actually grade 9 substitution, but getting this far is the tricky part. Negative 1.5 minus What's V initial? Yep, positive 2.5, but Amy, I'm not going to bother putting a plus sign in front of it because by default it's positive. Over, Sarah, what's the time interval we're talking about? Read careful, the time interval. What's T? Isn't it 0.2? Yep. Now, folks, with your calculators, how many numbers are on top of this fraction, 1 or 2? If you're going to do this in one step, you have to put the top in brackets. In other words, watch. The most common mistake kids make, even my physics 12 still do this, they go, oh, this is negative 1.5 minus 2.5 divided by 2. Your calculator does not know that that negative 1.5 is supposed to be divided by 2 as well. This is not the right answer. So you have two options. You can either go, if you're a math nerd, bracket negative 1.5 minus 2.5, close bracket, divided by 0.2. By the way, I typed a 2 up here. I should have typed a 0.2. You can do it that way. Or you can do the entire top on your calculator. You can go, hey, what is negative 1.5 minus 2.5? Sorry? Negative 4 over 0.2. You can do that. What is negative 4 divided by 0.2? Need more room, Mr. Duick. Sorry, what do you get? Negative 20? Units. What do I measure acceleration in? Meters per second was velocity. Do you remember what did we say we measured acceleration in? Meters per second, which we write as meters per second squared. What's the negative telling you? The acceleration was in the opposite direction that you were traveling. You were traveling forwards, you accelerated backwards. Example 2. A car accelerates from rest at 3 meters per second squared forwards for 5 seconds. What's the velocity of the car at the end of the 5 seconds? What the heck is this question asking me to find? Which one? Final or initial? I'm going to write down V final equals question mark. That must mean they must have told me everything else. Let's see. I'm looking for the 3. What's that 3.0? How can you tell it's acceleration without having me think too hard? The units right next to it, Kenzie, are meters per second squared. A is 3, and it says forwards, so positive 3 meters per second squared. What else do you see? A 5. What's that 5? How do you know? Seconds. There is one more thing that they told me, but they told it to me in English, not as a number. Can anybody see it? From rest. Can all of us right now, let's underline the word from rest. What does that tell me? What's 0? Yeah. What's 0? Initial what? Ah. VI is 0. What are they asking me to find? That's why I wrote that. So which equation of the ones in the box, of the ones on your green sheet, has the V final by itself? It says V final equals V initial plus delta V. By the way, what is delta V? What's changing anything? Now that would work great if I knew the final, but since I don't know the final, that won't help me. Hey, look on your formula sheet. Is there another way that we can write delta V? Is there an equation that has a delta V all by itself? Which one? Okay, we already said that, but the problem is I don't know V final, so since I don't know V final, that won't help me. Is there another equation that has a delta V by itself? What? Are you telling me that I can write this as that? Yep. By the way, that's the equation that I give my Physics 11 students. V final equals V initial plus AT. Because that one has no deltas, it's much clearer, and it's way more flexible. But anyways, I'm teaching you like Science 10 right now. You see how we made that little distinction, though? We wrote the equation that had what we wanted by itself, but then we said, wait a minute, Laura, by the way, can you see why I can't use this one? If I'm trying to find that, I can't use that to try and find that later on, right? Otherwise, that's my other one to try. Do I know V initial? Check. Do I know A? Check. Do I know T? Check. Then I can find V final. Now it's plug and chug. What was V initial? 0 plus. What was A? Positive 3 plus. What was T? 5. No calculator necessary. In your head, what's 0 plus 3 times 5? What's 3 times 5? 15. Plus 0 in your head? Units. 15 what? What do we measure? What do we find? V final. What do we measure velocity in? It's either meters per second or kilometers per hour, depending on what you started with. Yeah. Right? Those are our two velocity units for the most part in physics. Kilometers per hour. If you're on a road, we much prefer meters per second. Okay? Now we're starting to predict the future. We can start to predict how fast something is traveling given a certain acceleration. Next page. A train is traveling east at 14 meters per second. How long would, you know what? I missed the word words. How long would it take? You know what? Easier, cross out the word would. That'll work grammatically. How long to increase its velocity to 22 meters per second east if it accelerated at 0.5 meters per second squared? Oh, and it says, hey, let east be positive. All right, smarty peoples, what's this question asking me to find? Let's go process of elimination. Is it asking me to find acceleration? You know how I know? Because they gave it to me. What did you say, Darian? What word told you time? Now, how long is a tricky word because how long can sometimes be a distance? How long is a meter stick? 1 meter? Usually in physics, if we say how long, we're talking about time. Also because we don't know how to find distance with acceleration yet. So, Darian, you know what I'm going to do? I'm going to write down T equals question mark. By the way, Kenzie, the other reason I always do that for all of you, good test writing strategy. Hannah, have we written something down? Have we written something down? Yes, we have. I have learned over the years kids are now more relaxed on their tests because they've written anything down. Their stress level goes down. I don't know how your brains work that way, but Sarah, I've noticed that over the years. You write something down, even if it's just saying, I don't know what I'm trying to find this, kids do better. So trust me on that one. Now, let's walk through. That must mean, Amber, everything else is a piece of information. The first number that I see is 14. First of all, 14, positive or negative, and how do I know? East. What is that 14? Meters per second. So it's a velocity. Which one? Initial or final? And by the way, Brady, what we really mean is before or after, right? Initial. Let's write down VI equals 14. I keep reading. Oh, I see 22. Positive or negative? East, but just in case they had a direction change, I'd notice that. What's that 22? Sorry? Which final? Velocity. Because, by the way, Physics 11, you'll have more finals than just velocity. So I'm trying to teach you ahead of those that take it. V final 22. And I see that 0.50. What's that? How do you know? Meters per second squared. Positive or negative? Are you guys still on the same page? Okay, so you have all the equations still in front of you. Find the one that has the t by itself. There has to be one there somewhere. Time is change in velocity over acceleration, you say? I don't have a delta v. Oh, wait a minute. What is change in velocity? What's change in anything? Ah, this is going to be v final minus v initial over a. See how we're putting this all together? Now, plug and chug. What's v final? 22 minus, what's v initial? 14 over, what's a? 0.5. So you can either go brackets around the top, divided by 0.5, or you can go 22 minus 14 and press equals, divided by 0.5. If I do this in my head, 16? You called that a linden? I may use that for the rest of my teaching. Well, 10 years from now, none of the kids will get it, but I'll use that for a while. Number 4. By the way, time, direction, it's a trick question. No. So the one we just did, time, is there a direction for time? Time's a scalar. Time's a scalar. Okay, no direction. Number 4, a truck starting from rest accelerates uniformly to 18 meters per second west in 4.5 seconds. What's the truck's acceleration? What are they asking me to find? So yeah, but physics, it's usually pretty easy to figure what they're asking me to find. So I'm going to write down A equals question mark. Okay, let's list our data. What else have they told me? Oh, at rest, what's that? It's a velocity. Which one, initial or final? I'll underline the word rest. That's a key physics word. What's that 18? Direction. So we can call it negative, or we can write west. Let's make a little note here in the margin. West equals negative. So you're saying that the final velocity is negative 18? I'll agree with that. Then I see a 4.5. What's that? How do I know? I don't, but I just defined it that way. I could have let west be positive, but on the previous question, since we said east was positive, let's just be consistent. Doesn't really matter. There's no rule. In fact, in Physics 11, often I'll let whichever way produces the fewest negative numbers in my work, I'll let that be positive, because I know if I'm going to make a dumb mistake, it's going to be with a negative. Hey, what are we trying to find, Darian? Give me an equation that has an A by itself, please. You're saying A equals that? Good. Find A. Hast thou something to write with? Good. I'll look for your wonderfully done notes later. What's changing anything? And this one you don't really have to memorize because it is on your sheet, but it's worth having. If you happen to look that up, then I know you haven't done the homework, right? So this is going to be V final minus V initial over T, where the final is negative 18 minus the initial is 0 divided by 4.5. Negative 4? Ooh, the decimals in my head. -4 meters per second squared, because it's an acceleration. Or if instead of saying negative, if you wanted to give it a compass direction, this is why I just wanted to be consistent, what would that negative direction tell us? Okay, or we could say 4 meters per second squared west. I'm not sure which one they'll do on the provincial. I'll probably do a little bit of each on your test in terms of multiple choice. Written, I don't care as long as you're consistent. I'll mark it either way. Okay. Number 5. A toboggan moving 5 meters per second forwards accelerates backwards at -0.4 meters per second squared for 10 seconds. What's the toboggan's velocity at the end of the 10 seconds? By the way, accelerating backwards, if you're traveling forwards, you know what we call that? Slowing what? Slowing down. Okay? It just slowing down is kind of a vague one. This is better directionally. Justice, what are they asking me to find here? Which one? There's 2. By the way, please don't answer velocity because there's always an initial and a final, and I'm going to glare at you and say which one. So let's just decide right now. Which one? Yeah, thank you. Okay, let's walk through this question looking for either physics words like at rest or stopped or backward and numbers. First thing I run into is that 5. Sarah, my love, what's this 5? What are the units right next to it? So this 5 is a what? Velocity? Initial or final? How do you know? 2 ways. It's the first one, but also, well, I'm not trying to find V final. The only other one that can't be V initial. I agree. So VI is positive or negative? Let's let forward be positive. That's good, consistent. Sure. Jenny, the next thing I see is that -0.4. What's that? How do you know? Meters per second squared. Sure. Also, it says the word accelerates in front of it, so you probably would have figured that out anyhow, but Jessica, the last thing I see is that 10. What are the units right next to this 10, kiddo? Seconds. Which means it's a velocity, acceleration, or time? You know it. Okay. You guys all still have your little formula sheet? Give me an equation that's got V final by itself. V final equals what? Now the problem is I don't have a delta V written anywhere in my listed data, do I? Oh, and Laura, I can't use delta V as final minus initial because I'm trying to find V final. I can't, so I need another expression for delta V that doesn't have a V final in it. I think that's the middle column somewhere, yeah? What? That? I guess there's a delta in front of the T, right? We get sloppy. Time, because time is always a delta over the last couple of hundred years. Physicists have just said, oh, for Pete's sakes, we know that one's always a change in because you're always starting a stopwatch and stopping a stopwatch. We stop writing the triangle in front of it in physics 11, but I'll be consistent. Oh, plug and chug. VI, 5 plus A, -0.4 times T. What's my final velocity? Uno, eins, 1. Positive or negative? So which way are we traveling? This one doesn't say east. It uses a different word. Forwards. What if I'd gotten a negative answer? What would that tell you? What if I'd gotten 0? What would that tell you? You come to a stop. Okay. So lots of information here that we can pull out, that we can derive. Example 6. How much time does it take a car traveling south at 12 meters per second to increase its velocity to 26 meters per second south if it accelerates at 3.5 meters per second squared south? Okay. So far, this unit, Amy, we have been letting north be positive and south be negative. So we can continue that. In Physics 11, I would just tell my kids, oh, for Pete's sakes, Einstein said everything is relative. Let's let south be positive. But I just want to show you that this will work completely. We'll have to be more careful with our negatives and positives. But this will work if we let south be negative. Justine, it will. Justine, what are they asking me to find in this question? How much what? Thank you, Justine. It's amazing. I swear, your lips didn't move, and I thought it was coming from over there. You have a serious career if you choose to as a ventriloquist. That was impressive. Time. That must mean they told me everything else that I need. Let's see. I see a 12. Actually, careful. It's not really a 12. What is it really? Negative 12. What is it? And don't say velocity. Initial velocity? Okay. What's that 26? Well, first of all, it's a negative 26. And what is that going to be? V final? What's that 3.5? Acceleration, is it really a 3.5? Okay. I'm looking for an equation, please, that has t by itself. Time equals change in velocity over acceleration. Where, what's change in anything, pray tell? Which is on your sheet, but that's worth having in your brain. All right, let's be very, very careful. What's V final? Negative 26 minus, what's V initial? Negative 12. Can you see I'm going to have a minus minus, which is technically going to be a plus, but I'll type it into my calculator carefully. All over, acceleration is negative 3.5. So, if I go negative 26 minus negative 12, I think if you have a half-decent calculator, and certainly if you're in my math class, I've yelled at you about getting a good calculator for Math 10, you get negative 14 on the top, divided by negative 3.5. By the way, what is a negative divided by a negative? See, that's good because time is a scalar. If I got a negative time, then Einstein would be saying, I'm sorry, no, you've made a mistake. The universe is actually taking care of the math. What is negative 14 divided by negative 3.5? Is it 4? It is? Woohoo! 4 what? Meters per second squared? That would be if I was finding acceleration. But I'm pretty sure I'm not finding acceleration because I'm a good student and I've chosen to memorize the units so I don't make that sloppy mistake. 4 what? Seconds. Positive 4 seconds. This is a stupid question. And I'm only doing it because it shows up in the textbook homework and I have to assume that maybe it might show up on the provincial. Suppose our change in velocity was negative 90 kilometers per hour and it took 5 hours. What is our acceleration? Okay. What are they asking me to find? What have they given me? Okay, this time they did not give me a final or an initial. They gave me a change in velocity of negative 90 kilometers per hour. What else did they give me? A time of what? Now, double check. Do our units match? Is everything either in hours or in seconds. Everything's in hours. I'm okay with this. If they weren't, I might have to do some conversions, minutes to hours or something like that. Okay, what's an equation that has the a by itself? Sorry, you're right, whoever said that. There's something in front of the v. Okay. So you're saying it's negative 90 divided by 5. Negative, which means we're slowing down, 18 meters per second squared. This is not going to be meters per second squared. This is going to be strange units. This is going to be, what was the distance unit that they gave us in this question? This is going to be kilometers per, what was the time unit that they gave me? First of all, I hate those units. That's one of the reasons I wrote this is a stupid question. Here's the other reason this is a stupid question. Apparently you're driving your car at 90 kilometers per hour, and it took you 5 hours to slow down from 90 kilometers per hour to Can you think of a real life example? That's why I wrote at the bottom here, can you think of a real life situation that matches this? Me neither. Stupid question. But there is going to be one in your homework where they give you your speed in hours, they give you your time in hours, and they want the acceleration in kilometers per hour squared, which as a physics teacher I have never used in terms of the units, but I will give in to the people who wrote this textbook. What? Yes, I'm actually going to email them about this because it's, anyways. Turn the page! One of the best applications of gravity, of acceleration is gravity. Have I mentioned lately I jumped out of an airplane? When you drop something, it accelerates. So objects, as long as they're near the Earth and not in deep outer space, fall to the Earth due to the force of, help me out, gravity. Gravity is an attractive force that acts between two or more masses. In fact, believe it or not, all of you right now are pulling on each other with the force of gravity. It's just gravity is so small, you need something the size of the Earth before you really feel it. But technically, all of you are attracted to each other. Oh, air resistance is a friction-like force that opposes the motion of objects that move through the air. Air resistance, Hannah, is a very, very, very complicated force. It involves fluid dynamics and drag coefficients and cross-sectional surface areas. In fact, we really don't look at air resistance in Physics 11 or Physics 12. You really need calculus to deal with it well. So we're going to live in our magic physics world. Whenever we drop something, we're going to assume it's really aerodynamic and streamlined, and we're going to ignore air resistance. If you do that, if you ignore air resistance, all objects will accelerate towards the Earth at the same rate. What rate, you ask? What rate, you ask? Negative 9.8 meters per second squared. Very close to 10, and as a nerd, when I'm on amusement park rides, if I'm trying to figure out the g-forces, I'll use 10 to do the math in my head. In fact, that's what we did a couple of days ago when we looked at the little skydiving video, but really, it's negative 9.8 meters per second squared. In fact, if I were to do, and this is your first introduction to a velocity time graph, if you throw something, it has a positive velocity on the way up, but the velocity gets slower and slower and slower and slower and slower. At the very top, for a split second, what's your velocity? So we're talking about this. Look up! Right there. At the very top for a split second, how fast are you traveling? 0. That's this center section right here. Right there is when it hit the top. And then it continues to accelerate in the negative direction, so it's speeding up, it's speeding up, it's speeding up, it's speeding up, but in the negative direction. So, to analyze them, to analyze free fall, we use the same equations, except the acceleration, A, is negative 9.8 meters per second squared. Or 9.8 meters per second squared down, but I'm just going to call it negative 9.8 meters per second squared. Let's do a couple and then we're done. In fact, I think I have, 4 questions, 5 questions.
Can you go? I missed, or it was something, or.
I didn't write it on purpose. Or you can say 9.8 meters per second squared down, but I don't even like writing that. We'll call it negative. And I choose to ignore my angel Emily, as usual. Ready? Suppose a rock falls from the top of a cliff. What's the change in velocity of the rock after it has fallen for 1.5 seconds and let down be negative? All right. No, what's this question asking me to find? What's this question asking me to find? Let's write that down. What else have they told me? And then there's one more thing that they've told me that they won't actually mention in the question. If you know you're in free fall, if you're falling through the air, you know that. What did I just tell you the acceleration always is if you're falling through the air? They will never tell you that in the question. You'll have to clue in, we're in free fall. I need an equation that has a delta V by itself. You're saying the change in velocity is equal to the acceleration divided by the time. So it's going to be negative 9.8 divided by 1.5. I was making these numbers up. I doubt they'll work out evenly. Oh, it's times it. Yeah, that makes way more sense to me, Mr. Dewick. There you go. Change in velocity is acceleration times time, Mr. Dewick. It's going to be negative 9.8 times 1.5. Negative 9.8 times 1 is negative 9.8. Negative 9.8 times 0.5 is negative 4.9. Negative 9.8 plus 4.9, 14.7. Negative? Yeah. Woohoo! Units. It's velocity, meters per second. You're back? It's okay. What's that saying? That's saying that the object is increasing speed in the negative direction. Its change in velocity was negative 14.7 meters per second. It's sped up. By the way, when you drop something, what's your initial velocity? Think about it. What's my velocity right now? As a number? 0. When we drop something, we can assume, unless it says different, VI is 0. What's the next one asking me to find? Change in velocity. Did they give me a time? You know what? This is just like the previous example. Did we get the previous example correct? Then let's skip it, and let's go to the third one. A ball is thrown straight up into the air at 14 meters per second. How long does it take for the ball to slow down to an upward velocity of 6 meters per second? What are they asking me to find? Okay, let's look for key words. I see a 14. What's that? VI is 14. I see a 6. What's that? V final is 6. It does say upward velocity, does it not? Yeah. So I need one more thing. Oh, did we throw something in the air? Then what's the acceleration? Even on the way up, what's the acceleration? Yeah. All that means is on the way up, it's slowing down. It's accelerating downwards. That's just like when you're driving forwards and you hit the brakes. You're slowing down. It's just vertical now. I need an equation that has a t by itself. Which one has the t by itself? Yes? Change in velocity over a? Where what's change in anything? So it's going to be v final minus v initial all over a. Justine, what's my final velocity, dear? What did we write? What's my final velocity? What's v final? What am I going to put in there? What's v final? Just tell me.
Oh,
So yeah. You're overcomplicate. 6 minus, what's v initial? 14 over, we're in free fall. What's my acceleration? Free fall, because negative 9.8 doesn't go into an awful lot, this is where the numbers start to work out unevenly. So 6 take away 14 is negative 8 divided by negative 9.8. Let's round off to 2 decimal places, let's say. Unless it works out evenly, but I don't think it does. Now, if you got an error, double check your typing. It's negative 8 divided by negative 9.8. Make sure you use look up your negative button, not your subtraction button, because if you go subtraction divided by, your calculator will freak out. 0.82, if I round off properly. Seconds. 2 more, we're done. What are they asking me to find in this next one? What, Miller? Oh, let's write down VF equals question mark. That must mean they gave me everything else. Oh, I see the word initial velocity. What's my initial velocity? And I'm going to give you a hint. 8 is technically wrong. Why negative 8? It says we're throwing it downwards, yes? Oh, okay. So this is you're standing on a porch or a deck or a cliff and you're throwing something down, giving it an initial velocity of negative 8 downwards. So you didn't just drop it. What's that 1.5? Time? Did we drop an object or did we throw an object? Is it in free fall? Then what's the acceleration in free fall always? The question won't tell you that. You'll just have to clue in. Have I got an equation that has v final by itself? Which one? V final equals, is it v initial plus rats? I don't know the change in velocity. And Laura, I can't use final minus initial because I don't know v final. Oh, is there another equation that has a different expression for change in velocity? In the middle there somewhere. So you're saying this is going to be VI plus AT. Yes, yes. The final velocity is going to be the initial velocity, negative 8, plus negative 9.8 times 1.5. After 1.5 seconds, assuming it hits Curtis in the head, how fast it would be traveling? Negative what? 22? Anybody else? Negative 22.7? What's the negative telling you? Which way is this rock traveling? Up or down? Down. Units? meters per second. Last one. Emily, cheers. Terminal velocity for an average skydiver is negative 54 meters per second. When Mr. Dewick jumped out of the plane, have I mentioned jumped out of an airplane? When Mr. Dewick jumped out of the airplane, how long did it take him to reach terminal velocity? What's this question asking me to find? When I jumped out of the plane, was I in free fall? Well, then I know A is negative 9.8. If I ignore air resistance. What's that negative 54? It's A velocity. Initial or final? What was my initial velocity sitting on the edge of the plane there, struggling to get my legs onto the wing? What was my initial velocity? I think that VI, when I jumped, was 0, because I was in the plane. I didn't start falling yet. Now that I know that, can you reason which velocity must that negative 54 be? How long was I in free fall for before I hit terminal velocity? I need an equation that has the t by itself. Which one? Change in velocity over acceleration, where change in velocity, change in anything is what? Final, yes. My final velocity, negative 54, minus my initial velocity was 0, divided by negative 9.8. How long did I free fall for before I stopped speeding up? Sorry, 5.51? Not that long. You only free fall for a little while before the air resistance rushing up stops you from accelerating. Doesn't mean you're floating up there. It just means you're not speeding up anymore. 54 meters per second, that's about 120 miles an hour. Trust me, when you hit the ground, it'll still be fatal. But you're not going to go up faster and faster and faster and faster and faster. Homework! 2 things. So I've given you 2 handouts. One I'm going to assign all, one I'm going to pick and choose. This first one that's called Calculating Acceleration, just the front page, walk through it, the answers are on the back. This, do all of. The second one, which I called Gravity, which for some reason has 1 blank page, sorry, but when I photocopied I didn't know that was in there. Note, the acceleration due to gravity is negative 9.8. I'm not going to assign every single one of these. Let me see. I think you can try number 3, so you can skip 1 and 2. Number 4. Five is good. 6 and 7 is good. So I've skipped 1 and 2. Skip 8. But I have to do Felix Baumgartner's jump. I looked up these numbers, and these are accurate, by the way, in case you were wondering. So on October 14th, 2012, Felix Baumgartner jumped from the edge of space. If the speed of sound is 333 meters per second, how long did it take him to break the speed of sound? Oh, when he jumped, what was his initial velocity when he was standing on the edge of his capsule? 0. Just like when I jumped out of an airplane. I mentioned I jumped out of an airplane. And, yeah. There's your homework.
How's our friend Mr. Hatfield doing?
Quite well. Let me just hit stop.